Okay, year 13s, we're starting our trig identities here, and hopefully you'll remember from class we went over some of these. So with our first identity here, we're going to show that sine x is equal to cos of 90 minus x, and cos x is equal to sine of 90 minus x. And so if we're focusing on x here for a second, then this side would be adjacent, and this would be hypotenuse, and so we could say that sine x is equal to this side that's labelled A and this side that's labelled C. So A over C. Now if we look at cos of this angle, which is 90 minus x, so 90 minus x, that is going to be B over C, because it's adjacent over hypotenuse. B over C, and that makes me realise that I made a mistake with the first one because B is opposite, so it should be B on top there. Okay, so because these trig functions are equal to the same fraction, they are also equal to one another, and so that means that sine x is equivalent to or equal to cos 90 minus x. So the three letters there mean that they're equivalent to one another. A slight difference from equals. Equivalence is just meaning when you've got functions that have equivalent properties rather than some particular value being exactly equal to another. So slight difference there compared to our usual use of equals. Okay, so that's showing the first one, and it's basically the reverse process to find the other one. So if we focus on this one for cos, we can say that cos x is equal to A over C, and sine 90 minus x, that's equal to A over C as well, and so cos x is equal to or equivalent to sine 90 minus x. And so those are the two formula or two identities that we have there. Okay, for our next identity, we're showing that sine x over cos x is equal to tan x. So let's look at sine x. So sine x would be B over C, okay, so that's opposite over hypotenuse, and cos x would be equal to A over C, so that's adjacent and hypotenuse, and tan x would be equal to opposite over adjacent, so B over A. So what we want to show is that these two things being divided by one another are equal to this. So let's see if it works. So B over C divided by A over C, that's the same as B over C times C over A. Hopefully you know your fractions. So our C's cancel out, and all we're left with is B over A, which of course is equal to tan x. So that means that sine x over cos x is equal to or equivalent to tan x, and that's how we arrive at that identity there. Okay, our last identity that we'll go through in this video is sine squared plus cosine squared equals 1 squared. And so here we've got a triangle with sides A and B and a hypotenuse of 1. So using Pythagoras' rule, we could say that A squared plus B squared equals 1. And we'll just leave that there for now. So in terms of sine, if we're writing sine x, that would be equal to opposite over hypotenuse, which is just B, and cos x would be equal to adjacent over hypotenuse, which is just A. And so substituting this in for B and this in for A, what we get is, and it doesn't matter what order we put it in, sine squared x plus cos squared x equals 1, which is that formula that we've shown up there. So these three formula come in useful, and we'll look at some examples of where we can use them in our next video.